want to talk about the kind of impact that AI is having on us, on society, humanity, and then kind of what we can do about it. So in this presentation, I actually put a lot of links that you guys can follow, and later on, either during the Q&A session or even after it, you can always contact me at one of these email addresses. So I'm very happy to have this kind of scientific interactions. So again, the slides that I'm using are here at this link. Centik.net is my website /2026 SciSpace.pdf. But again, if you don't catch it, you can ask me later. So AI, I don't need to tell you, is quite ubiquitous these days, and there are a lot of discussions on how it's changing humanity and the world and the economy and society. One hot topic is definitely about jobs, so much that people like Geoffrey Hinton even tells you it's better that you train to be a plumber rather than studying computer science. But he's not the only one. Some people like Jensen Huang say that there is no need for you to learn how to code anymore because you can just vibe code, right? So I personally, I don't agree with this. We can discuss this later, but the point that it's fair and true is that uh, um, technology has always been there, progress has always been there. But what's different between this revolution and past revolutions like the Industrial Revolution, the Internet Revolution, and so on, is that now for the first time, it's the white collar jobs that are at risk and not the blue collar ones. But still, if you are interested in this topic, you can read this IMF reports that really discusses how we can be better prepared as a country and as a society to this kind of shifts. It's also a question, as I'm sure you heard, about human creativity, right? Now, more and more directors and movie producers, but even book writers, they are using AI to for their creative, as at least as part of their creative process. Even artists, right? So there are some questions that we like to ask, such as how long will it take before all the possible texts will have been written? So not sure if you're familiar with the concept of the infinite monkey. So you put the monkey in front of a typewriter, there is a non-zero probability that it will write something that makes sense. So if you have infinite number of them, it will happen at some point. So what if we replace the monkeys with LLMs? How long will it take for them to write all the possible texts so that after that point, that plagiarism, singularity, everything will be plagiarized? So if you are interested in the details, you can read the paper. It's at this link, but again, we can discuss this later. It's also the big question about how AI is affecting society and the kinds of relationships that we have with each other, with co-workers, with partners, with friends, and so on. And the trajectory is quite it's quite alarming because then we have all these chatbots, but also recommender systems that know us better and better. So the temptation is just to be interacting with these rather than interacting with real people, right? And now in Japan, there is also this tendency to get married to AI, to a hologram or a robot or even a chatbot. There's also some this phenomenon is also happening in some corners of Singapore. On CNA, I saw recently a documentary on this. You can also look at that. It's called Buddies. But so we're slowly transiting from sort of attention economy to a relationship economy, because then as soon as we have these personal chatbots that are helping us, or personal agents that are helping us buy stuff, order books, and even do some of our work, it's really a sort of relationship that we are establishing with the businesses that provide us with products and services. The important question is, how do we make sure that such relationships are not exploited? And so so for all these slides that I'm talking about, if you want to know more details, you have the links of the papers at the bottom. Another thing that we explored recently is AI overload. So with all these AIs available, some, especially younger students that they just started university, they can be a bit stressed about whether to use AI or not, and what kind of AI and for what. And it can be kind of overwhelming as well, in a sense that AI can do so much for you. So where to start, how to use it. And so in the past, we had so-called information overload, and now we call this AI overload. So in this short paper, we discuss how the types of overload that AI can create at different levels, at individual level, at organizational level, and at societal level. And we also worked with the School of Nanyang Business School in NTU to see how it's going for SME, small and medium enterprises, with their adoption of AI. So again, if you are a young worker that just entered the workforce, maybe it's easier for you to adapt. But what happens? How can we train more senior employees? Always becomes a problem. But it's not just about work and jobs, it's also about the way we use AI for our daily lives. And it can be a bit intimidating or overwhelming sometimes. And in many cases, also, we see a lot of bad examples, like idiosyncratic uses of AI that can result in things like this, like people forgetting to remove parts of the result got from ChatGPT in emails. This happens to me many times. Like, not that I do it, but I receive emails that are clearly written using an LLM, and they forget to remove things like, do you want me to make the email more persuasive, or something at the bottom? Or like you see some reviews, the prompt has not been deleted, and also in job ads, and sometimes even in the newspaper. So this just to clarify that we're still at the beginning of this kind of AI revolution. So it takes some time maybe to understand how and also when to use it. Another problem that not many are talking about is the fact that all these foundation models, they actually require a lot of data centers that generate a lot of heat. They consume a lot of electricity and water, so much that they are literally changing. They're like a microclimate in some places that are affecting animals and humans. So this is something that we are also interested in terms of AI efficiency. So the things that we have done so far, and even when you read scientific papers, they're mostly focusing on accuracy, but not much on efficiency. So questions like, instead of saying like, how can we have a better accuracy on these data sets, I seldomly hear things like, okay, given the same accuracy, how can we make the system more efficient, like using less resources? And if we don't do something about it at large scale, then we may have serious problems. So we are at sort of a crossroads where we can decide whether to go ahead with our brute force path, because that's really what we have done so far. So the big revolution in AI was mostly driven by the usage of transformers. But transformers are nothing much more sophisticated than what we used in the past. The only one important thing is that they can be parallelized, so we can put more and more hardware on the table to have better performances. But is this really the best way to emulate intelligence? Maybe not. So when we talk about intelligence, we also have some interesting papers that look at it from a philosophical perspective. What is intelligence and how it got to evolve in us, but also other animals. And one important point here, in line with what I just discussed, is that intelligence always comes from efficiency. So how to most efficiently use the resources that we have at hand to then complete a task in the most efficient way. So what I'm talking about is that, for example, the human brain, it's actually extremely efficient. So it can be compared to what a large language model does, but it's occupying very little space and it's not really consuming a lot of energy. So, and how can should we look at nature to have more bio-inspired ways of creating or of emulating intelligence? And so this brings us to the paper that Deepak was talking about. So this is again a sort of philosophical perspective, but it's important because then when we talk about AI, we tend to look at it more from a practical point of view, the technological changes that AI brings about or the societal changes. But it's also like on a personal level, it's something that we haven't thought about much, but it's one of those so-called narcissistic wounds that Freud talked about. So the first revolution or narcissistic wound was that we were no longer at the center of the universe, thanks to Copernicus. The second by Darwin, that we are not so different from other animals or primates. And Freud then made us discover that we are not fully master of our own minds. There is the subconscious that we don't have much power on. And last but not least, with AI, now we have this fourth revolution that makes us no longer the only intelligent or highly intelligent beings in the universe, and this can be frightening again for some, but again, it's all about understanding what are the strengths and weaknesses of AI and how we can get along with it. Fun fact, in the original version of this paper, because all these prior revolutions come after the name of the people that started it, I initially called this Hintonian revolution after Geoffrey Hinton. But then, after he became a co-author of this paper, he was strongly against it, maybe being very humble. And so in the end, we called it intuitive AI revolution. So I don't want to spend too much time on this. If you're interested, you can take a look at the paper. It's open access, published on cognitive computation. But so again, we talk about AI, we talk about intelligence. Intelligence is actually one of those suitcase words that we kind of get, but then it's not so easy to define, right? If I ask you to build intelligence from scratch, it's far from easy. And so we look at all these things, like, for example, the difference between human cognition and AI cognition. And one other thing that we discover in this other paper from cognitive computation is that the way we perform even a simple task like question answering, it's usually very much grounded in very concrete concepts, maybe based on our own personal experience, while ChatGPT tends to gravitate more around very, very abstract concepts. So the way reasoning is done, the way a task is accomplished is very different between human and AI cognition. So the truth is that we still don't know actually how the human brain works. Yeah, we have a better idea thanks to cognitive sciences, but still, we don't actually know even how simple cognitive processes like memory actually work. So it's like the brain is like a black box. It's like we know the hardware of the brain, but not the operative system. So that's what makes it hard to emulate, right? And that's why we took that brute force path. And as I mentioned, it's also the efficiency, the neuroplasticity of the brain that is something so amazing that we haven't been able to emulate yet. Why? Because it took millions of years of evolution to get there. Another hot topic these days is about artificial general intelligence, AGI. And the big question is whether we'll ever get there, whether it's actually possible or not. But it again, it all depends on how we define intelligence. So definitely foundation models, large language models will become cleverer with the years, but then maybe they will never truly understand the meaning of things like emotions, pain, pleasure. Why? Because they are just living in their own black box and they don't really see or experience the world the way we are. So maybe it's also important to define the difference, to distinguish between biological intelligence versus non-biological one. But on the other hand, you have people like the late Marvin Minsky that say we are also machines. It's just that we are perfect machines. We work so well that there is actually no difference. And it kind of makes sense if you think all the things that our body does in a kind of pre-programmed way. We don't have full control on our bodies. A lot of internal organs are kind of pre-programmed by natural evolution. And some others go as far as saying that the role of us, of humanity, was just to create this AI that in the end will be here much after we are extinct because it's free from biological limits and, for example, will go and colonize the rest of the universe. So these are again all philosophical questions. Sorry, I'm giving you more questions than answers. But one thing that is important to do right now is to try to engineer the future of AI so that we kind of have some kind of control, or at least we can better understand it. But it's not an easy task because then again, where to start, what to use as a model for this intelligence? Are we humans even a good model? That sounds like a stupid question because we are the pinnacle of intelligence, right? But then it's not a stupid question because then a lot of foundation models are actually inheriting not just the good stuff, but also the bad stuff like gender bias and race bias and so on. An important question is also whether to inject the full spectrum of emotions into intelligent machines. And this is also an open debate. Should we just keep out the negative ones or also include the negative ones? And it may, again, sounds like a stupid question, like why do I want my computer or my chatbot to be angry with me, right? But then there are important emotions like frustration that we actually need, although negative, to then really emulate intelligent behavior. And this is also something that we just discussed. Is it okay to feel something for artificial intelligence? Also, if we talk about embodied AI, how should they look? Should they look more like us or not? Again, these are questions that go on from the 70s. This is the famous uncanny valley problem. Also, should we put a cap on how intelligent AI can be? And finally, how fair would it be if we really emulate intelligence to keep it trapped in a server, in a computer, in a phone? So it's an open debate, and different AI professors think differently. So here in this paper from 3 years ago, you kind of have them charted depending on how much they think that there's going to be a disaster caused by AGI and the probability of AGI to even happen. And this is also exuding then into the business world. Of course, Elon Musk, Jeff Bezos, Mark Zuckerberg, they have very different ideas of what AI can really do for humanity. And personally, I don't have I don't believe in those apocalyptic scenarios where AI is going to kill us all, but there is always the risk that we build an AI with a specific purpose and then we experience some unexpected consequences. Like if we have an AI that is autonomous enough to then be able to fix climate change, then it may think that we are the problem and eliminate us all. But otherwise, AI per se is neither good or evil. So these that I just mentioned are also named paperclip scenarios, where you create an AI that has the goal of creating paper clips, and then it goes on and uses up all the resources on Earth to create paper clips. So this is also an important question in terms of goals. What motivates us, or intelligence, behavior in general, to act. And you may say, okay, how are these paperclip scenarios likely to happen? It's impossible. Like, it's very unlikely to happen. The truth is that we can't see very far in the future, and so we never know what kind of impact a new invention is going to have. And so about a century ago, for example, plastics were an amazing invention that made us progress so much, but today they are actually threatening our own existence. And I'm not just talking about the plastic that floats in the ocean, but also things like microplastics. And even if you think about social media, they actually achieve their initial goal of keeping us glued to our devices. But then, is this really the kind of future that we want? Could we expect this? And these are things that, in general, it's hard to predict. But then what to do? Like, can we stop it? Should we stop it? Actually, we learned from history that progress cannot be stopped. So the only thing to do is to embrace the fact that AI is here, and then understand once again how to use it, when to use it, how to interpret it. So with all this in mind, we came up with these pillars for the future of AI, which is not a futuristic vision of what's going to happen in the future. It's more like a sort of research manifesto, or a call for collaboration if any of you is interested in working on these topics with us. So the first thing to understand definitely is that AI is no longer just a computer science discipline. And then there is this tendency to just dump as much data as possible into a system and then expect this to magically be able to do all the tasks that are required. But sometimes it's better to apply some sort of task decomposition to understand what the system is really doing. So I talk about this in my course that I'll share the link of later, but also in our AI scientist. So this is also something that can be maybe very interesting for you guys. We developed this framework called Moose, which is made of a lot of LLMs that are talking to each other. And then this can be used for scientific hypothesis generation. We use that for social sciences and chemistry, and it works quite well. It helps you to come up with new ideas that you can then further investigate for research. Parallel analogy is also something that not many are doing. As engineers, we tend to optimize everything, the data representation, the reasoning processes. But sometimes it's good to have redundant representation of the same data or of the same cognitive processes, so that we can switch from one to the other when problem solving starts to fail. Another central pillar is symbol grounding. So today, large language models mostly work with embeddings, but then these embeddings are not grounded anywhere. There is no internal representation of what each of these verbs or nouns actually represent. That's why many AI researchers today are talking about world models. So on top of having an LLM, let's say, as a front end, on the back end, you should have a world model that kind of grounds meaning in some sort of representation. So this is what symbol grounding does. Similarity measure is also important concepts. Today we have better and better models, but in many cases we are still using things like Euclidean distance and cosine similarity that are not topology aware. Can discuss this later if you are interested in this topic. Intention awareness is also very important for human to human communication. We always have an idea of who we are talking to and what is the kind of ideas that we want to transmit, what kind of expectation we have from the interaction. So I'm talking about things like theory of mind, but also personalization. And last but not least, trust. How do we define trust between human and AI? So this is also coming from the link that I shared earlier about responsible recommender systems. How can we make sure that the items that our recommender systems provide to us are really in my own best interest and not following maybe the business model of the company? So these are important questions to ask, because then we are basically surrounded by recommender systems. Everything we use is a recommender system, from Amazon to Netflix to dating apps. Everything is a recommender system. But the problem is that we are fed results and there's no explanation on why and how these results are fed to us. So this is in a nutshell the 7 pillars of AI. Feel free to take a look. This is also a short paper that you can quickly look at, and let me know if you have any questions. If you want to know more about these topics, like AI basics, data science, neurosymbolic AI, natural language processing, there is this free course online that you can find on our YouTube channel, or you just can follow this link, nlu.centik.net. There are also a lot of like the slides, FAQs, tutorial quiz that you can download for free. So where does that leave us? What's next? What's the future of job? What should we focusing on? Again, I don't have the crystal ball, but the I think a smart way to tackle this is understanding what AI can do for us, what kind of tasks can be automated in different jobs, and then come in with your own human touch, with your own human expertise, with your own human creativity to really create a synergy. So those, I think, will be the jobs of the future. Some jobs indeed will be replaced, but those that always require the human touch or the human input, then will still be there. So for example, now many are using bots or AI in general to perform financial predictions. But then a better way to go about this is that you always have a human in the loop, a financial advisor that can take the final decision based on what the AI is giving to him or her. So, and this is because today we're still at this situation which is kind of a paradox, that for the high level reasoning tasks, these are easy to program, AI can do, but the simpler things that we learn in the very early years of our lives, AI cannot do. So in general, I'm an optimistic. So I think as long as we can find the right synergy, the right strength and weaknesses of AI and biological intelligence, then I see a future for humanity and the future of jobs. And then there's also the concept that it's not just about AI that is learning from us, but also we can learn from AI sometimes. So in the game of Go, for example, Go masters are learning some new tactics based on how AI plays Go, and also in the context of finance, as I just mentioned, sometimes the decision that AI makes that are not as emotional as it could be for some financial advisors are better in the long run. So maybe we can also learn something there. Recently, we also have this short paper on PAKDD that tells you a bit more about AI adoption. Again, you can take a look if you're interested. If you're, let's say, developing an idea for an AI startup, it's totally fine to use an AI that an API or ChatGPT or whatever else you can find. The benefit of building your own AI model is that you can then have interpretability of the model so that you can do, for example, an ablation study or some error analysis to later improve your system. Based on the interpretability, then you can have also the explainability of the system. So interpretability again is for the engineer, while explainability is more for the user. But then here, and many stop here. Like as long as you have some explanations, then you can be happy. But actually, who tells me that these explanations are good? They could be just randomly generated, right? So we need to work also on evaluation of these explanations, build trust based on utility, how useful these explanations are, robustness, if I keep asking, do I get the same explanation? And finally, faithfulness, is this really how the system generated the output? And finally, the holy grail, as I already mentioned, is having a human in the loop that can decide whether they like or not a specific output and ask the model to make some modifications to then get a different output. So I want to leave you with this before then I maybe spend a few moments on telling us what we're working on. If you never encountered AI yet in your job or in your research, don't think too much. AI is just a tool. So again, it's neither good or evil. It depends on who and how is using it. So you can think of it a bit like a car. So for example, you don't need to know what's inside the car to be able to drive it. And there are different models available out there. So you need to think which one is best for you, for the things that you do. You can also have using model A for something and model B for something else. And then the fact that you have a car doesn't mean that you drive all the time. Sometimes you can also walk, right, or take a train. So when is it smart to use AI and when instead it's better to do things on your own? Also, the kind of speed that you're going at and how and when to use it is something that you have to try to incorporate in your routine. And as we said, in the interpretability and also explainability of the system is important to really know what you're doing, like how these models are taking decisions for you. And then once you know that, you can also customize it to your own liking. But in general, the most important advice I can give you is to stay curious about it because things change very fast. New tools are coming out every month, and also new architecture. So there is no chance to just sit and relax, which makes it very exciting, but also can be annoying for those that just want to learn one thing and go along with it. So this is basically all I wanted to share with you today. And here I put some links to some of the stuff that we're working on again, in case some of you want to work with us. We work on explainability. So mostly we work on NLP, but affective computing. So we look at personalization, different levels of personalization in the context of affective computing. We focus mostly on text, but we also look at speech and video, like facial expressions, recognition, for example. We focus mostly on English, but we also look at many other different languages like Chinese, Spanish, and more. We explore different kinds of architecture, especially how different tasks can be tackled concomitantly. And then we have our own affective chatbots and empathetic dialogue systems. And finally, something that we're working on at the moment is emotion prediction. So the big bulk of affective computing research is really just emotion detection. But then since we are working on explainability and personalization, the question here is, can we predict how different people will feel if event A or B happens? And this can be a powerful tool again for financial forecasting, but also political forecasting and so on. Here's also a list of more practical projects that we use those umbrellas for, from business intelligence to climate resilience. So we look at things like greenwashing detection, but also corporate sustainability. Being in education, we also use affective computing to monitor how students feel about their learning experience. And here, this is the one that I mentioned early. Moose is our own AI scientist that we tested in several contexts, and it works pretty well. It really suggests interesting research ideas that can be then further investigated. We work on healthcare, specifically on mental health care. So we look at how affective computing can help explainable depression detection or suicidal ideation detection. We also use our tools for countering phenomena like cyberbullying or cyber harassment and sexism online. And finally, as I mentioned, also finance can be pretty exciting, not just about collecting and processing text, but also concomitantly looking at technical analysis to have a more holistic and precise vision of where the market is going. And then we put all these things together to develop our own foundation model that it's called the Human Behavior Atlas. So I'll leave you the link here. It's also available on our GitHub, and also all the data sets that we collected and use for emotion expression or emotions from text, but even pose and speech. They are all there, and so you can take a look if you're interested. The last thing I want to share is also that beyond explicit sentiment analysis, we also try to look at how people feel about different topics implicitly. And for that, we use a sort of automatic word association tests, like the one that you saw in James Bond. So I ask you a question, you tell me the first word that comes to mind. Now, of course, doing this would take a lot of time, but then if we use metaphors to understand what kind of concept mapping people have, then we can tell a great deal about how they feel implicitly about different topics. So here, for example, James Bond associates heart to a target rather than love. So by looking at these associations, we can tell a great deal about the personality and the likings, the preferences of people. So that's all. In the last few slides, I give you some links to some call for papers and departments that are always accepting papers on these topics. Here you have AXA, Affective Computing and Sentiment Analysis Department on IEEE Intelligent Systems. Then we have this special section on cognitive computation. There's also a book series if you're interested. And every year we met in ICDM, International Conference on Data Mining, for our workshop series on sentiment analysis. We have a YouTube channel where we usually post short videos about our recent research investigations, and a lot of free downloads that you can get from our website, from Sentinel to other things. And of course, we are also on GitHub if you're interested in using some of our codes. We are working with AI Singapore to develop an open source, a multilingual language model. It's called Sea Lion. And then there are other tools like the one that I just mentioned for metaphor detection and understanding. And finally, also the Cintiq APIs that allow you to do some of these tasks in a very easy and straightforward manner. So if you use the APIs, which again are free to use for research, then you get this kind of very formatted output and that gets printed onto an Excel, or alternatively, you can just use the user interface to test some texts that you have. So here on the UI, you can see how the same APIs are visualized. Okay, that's all. Once again, these are the important links. Happy to take any questions now or later. You can always find me on one of those email addresses. Thank you for your attention.
Uh, Hey Eric, thank you for the presentation. There are two questions, one in the Q&A and one in the chat section. Uh, could you please open the chat? The question is too long for me to read.
Okay, so is it the one from
From Stuart Nolan.
Stewart? Okay. Physical. Oh my God, why is this? Okay. So Stewart is working on physical empathy research in business and healthcare. Empathy is composed of cognitive empathy, emotional empathy, physical empathy, requires a body, yes. This suggests I cannot develop comparative empathy, yes. Yeah, so there are a lot of people that are working on trying to expand the kind of perception space that AI can have. That's why now robotics are hot, embodied AI is hot, but that doesn't really solve this kind of problems that you mentioned. So it's more about those that are working on things like smell understanding, smell detection, or other kinds of perception of the world that we have that goes beyond just analyzing data. So even when you talk about computer vision, it's not like if I feed videos and images, the AI model can automatically understand what's in them. That's why people now talk about word models rather than that, because then if I have images and videos and I just represent them as embeddings or just association of pixels, then what does that give me? So I don't know about any research at this moment that are focusing on this, because then we're still far from there. Like we're still trying to figure out how we can embed even like emotional intelligence into robots, which in many cases is very artificial, right? You see, if you try to, don't know if you ever played with some of those social robots, their answer is always like you can see that it's very artificial. You can never feel that the emotions that a robot is exposing is really felt by the robot. So that's what I was talking about earlier when I talk about the fact that, for example, it would be good for a robot to feel frustration sometimes so that they don't get stuck. But at this moment, we are just at the level of emotion detection and trying to give an emotional feedback to the user. So yeah, this research direction is very interesting, but I don't know anyone that is working on this specific problem at the moment. Okay. Yeah, I'm happy to talk about this more in detail later on if you have time to see what you have done and how and if I can help or if I know someone that is working on this problem.
Awesome. So I've sent two more questions to you from the participants. Question one is, do you think the AI weights may hold some latent perspective of knowledge that is not obvious, that only exists in a human?
Sorry, Chris, can you repeat?
Do you think the AI weights may hold some latent perspective of knowledge that is not obvious and that only exists if a human asks the right question to the LLM to find it?
Yeah, so sometimes when you use ChatGPT or even like when we use our own AI scientists, we see sometimes results that we didn't expect, that we didn't think about, and this is good because then many of these foundation models are creative in a sense. They generate new information that maybe wasn't even in the training data. But then again, we need to find a trade-off between um, how much they can do this and how much we can trust this output, because then unless I have the time and will to check whether this newly generated information is true, it can be tricky. So this is why people are looking at, for example, hallucination score. Hallucination, we tend to connect it to some very negative concepts, but actually hallucination allows the system to be more creative, to go much, to interpolate between data points that it doesn't have in the training data. So yeah, I believe that that is true, like it's happening in our AI scientist model, but you always have to have some guardrail like we have in our model. If I manage to go back to it. So in that framework that I briefly shown earlier, you have, for example, an LLM module that is coming up with some ideas, but then we have another one that is doing some sort of reality check. So it's good that the one of the modules can come up with new scientific hypothesis, but then you always need some kind of control in there to make sure that, for example, the idea is new, the idea is feasible, and so on and so forth.
Uh, Fair enough. The next question is how ethical issue of AI can be taken responsible.
How ethical issues of AI
AI can be taken responsible.
can be taken?
Responsible.
I don't understand the question. Uh, you
Yes, sir.
mean you're talking about accountability or?
Accountability, yes.
Uh, yeah, this is also a hot topic right now. So if you build an AI, or if you're using an AI to do something and it has unexpected consequences, then whose fault is it? So this unfortunately it goes beyond technology. It requires regulations. So yeah, ultimately, I think it should be the responsibility of the company that puts this AI models on the market, even if it's free to use. So it's similar to like maybe drugs or pharmaceutical products that need to be heavily tested before they are made available to the market. But this actually is not happening much at the moment, because then there is this rush to create the best AI model. And so at the moment, there is not much testing going on. So yeah, these are important topics that in some countries, like in the European Union, are considered important, but in other places like maybe US or China, not so much, unfortunately.
Got it. The next question is can AI help humans to increase their cognitive behavior? If so, what are the restrictions on this? Because this might cross the psychology boundaries.
I don't understand what they mean about psychological boundaries, but definitely AI has the potential to be like your private tutor. So that's also why, for example, at NTU now we completely changed the way we are teaching. I no longer go to class and do a lecture like in the past. I pre-record my lectures, and then when I go to class, we discuss. Why? Because then You can potentially use AI to ask questions about your lecture, and so there is the potential really there to learn more, to even increase your IQ, your habits, your life in general, if you can learn from it. But then the risk is what is that you may get too reliant on this. So it's important also to have a threshold that allows me to understand when and if when to use AI. Otherwise, the future really looks like this. As I mentioned, the recommender systems or chatbots that we use are just so good that we no longer even want to talk to other people, because what if my chatbot or my personal assistant on my phone understand me better than anyone out there? And so is this really the future that we want? Is it really good for me? Actually, we humans are built for like interacting with each other. We will fall sick, like mentally sick, if we don't do that. So it's all about finding a trade-off. So it's fine to use AI when you're studying, for example, but then you cannot just use it for everything. And then it's time when it's time to go out there, then yeah, you need some kind of boundaries that allow you to live a healthy life. So I'm not a psychologist, but yeah, these are some of the things that we try to discuss about in this paper, and also the more recent one about the relationship economy.
Great, awesome. Is there a way how attendees can get in touch with you, your email or something? Because there are like good amount of questions. I'm not sure if you can answer all the questions, though.
Yeah, no, actually, I have another meeting at 3 p.m. But as I said, I'm always very excited to discuss about these topics. So
Mhm.
uh, they can always find me at these either at my NTU email address or my MIT address, and I receive a lot of emails, so I'm a bit slow, but yeah, I tend to reply to all of them. So yeah, you can find me there, and if anybody is in Singapore, of course, they are most welcome to come and visit me at my office every Thursday.